Alright, we're going to find the derivative of f of x equals the fraction x plus 3 on top and x minus 5 on bottom. So I guess it's worth just go ahead and stating that our derivative formula, in case you don't remember, f prime of x equals the limit as h approaches 0 of the fraction f of x plus h minus f of x all over h. And if that's the case, we're going to need to find a couple things. Given to us is f of x, which was x plus 3 over x minus 5, and x plus h will be x plus h plus 3 all over x plus h minus 5. So in that case, we'll go ahead and set up our limit here. So our limit as h approaches 0 of f of x plus h will be x plus h plus 3 over x plus h minus 5. And that'll be minus f of x, which will be minus x plus 3 over x minus 5. And all that is over h. And just something I like to do, is not necessary, but just to keep things straight, I'm going to write that as h over 1. So it looks like a fraction over a fraction. Let's move this guy down. So what can we do here? Well, we need to kind of figure out a way to cancel out this h in the bottom, because even though I've written it as h over 1 is 0, and we can't divide our fraction by 0. So what we need to do is kind of figure out a way to do common denominators up here. So I'm going to take the next line, and it's going to be pretty horrific, but it'll look like the limit of h approaches 0 of the first fraction was x plus h plus 3 all over x plus h minus 5. We need to have this as a common denominator with the other fractions so we can combine them. So I'm going to multiply it by x minus 5 over x minus 5. So that'll give us the same denominator as the second fraction, and it'll just be 1, so it really doesn't mess anything up. So then we're going to subtract the second fraction, which was x plus 3 over x minus 5, and we need that common denominator from the first fraction. So that'll be multiplied by x plus h plus 3. Excuse me, not that. We need to multiply by the denominator. I'm getting a little too excited here. X plus h minus 5 over x plus h minus 5. So once again, this is over h over 1. Now, they look like they have common denominator, but we've really got to clean that up, and it's no fun at all. Let's keep working. Push, push, push. Limit as h approaches 0. Okay, it's going to have a big fraction up top, and that fraction is going to have one common denominator of x minus 5 times x plus h minus 5. And then it's going to be all over. That was supposed to be a different color. It didn't come across, did it? Now it's there. We'll make this line very heavy. All over another fraction that is h over 1. So now we really got to work on the numerator of the numerator. So we've got to foil this first thing together. X plus h plus 3 times x minus 5. So let's see what happens when I do that. Take it slow. X squared. It's not a full because there's too many terms. I'm multiplying the x into the other one. So minus 5x plus xh minus 5h plus 3x minus 15. Lots of room for mistakes to happen. Minus the second one, pushing the x plus 3 into the x plus h minus 5. I get x squared plus xh minus 5x, then plus 3x plus 3h minus 15. And remember, all of that is being subtracted. So let's pull this guy back up. We didn't actually use that space. So we've got a huge fraction, which is a fraction over a fraction. I know it looks messy, and it's kind of hard to predict how big it is until you do it. But let's see here. Let's clean it up while we're here. In the first, we'll just clean up the numerator of the numerator. So in the first one, we've got x squared, and then we got a minus x squared. Those will go away. We've got a minus 5x and a minus 5x. Those will go away. We've got a plus xh in the first part, and we've got a minus xh in the second part. Those go away. Let's see, do we have anything else that'll go away? Yeah, we've got a 3x in the first part and a minus 3x in the second part. That will go away. What else do we have here? We've got a minus 15 and a minus 15. So let's get a new color. Not too many new colors to choose from. There's an orange. So we're going to do, oh, that was not what I expected it to be. Pause. Okay, we're back. So here we had a minus 15. Trying to make sure I've got the color I want. And then we'll have a minus 15 in the second one, so those will go away. So let's see if we've got everything else here left. Okay, so it's actually pretty simple here. I'm going to need more room, so let's move down a little bit. We may have to move our next problem down. Let's go back to our regular colors up here. So if I clean all this up, what have I got? I've got the limit as h approaches 0 of a great big fraction, but I'm going to write it a little bit differently this time. I'm going to write it as the fraction that I have, which looks like negative 5h minus 3h. So that looks like negative 8h. And then on the bottom I have x minus 5 times x plus h minus 5. Now remember, that was all divided by h, which I wrote as h over 1. So we're going to do a keep change flip and write it as 1 over h. So when we divide fractions, we can keep change flip and turn it to multiplication. So I have this h in the top and this h in the bottom that I can now cancel, which that h in the bottom was the thorn the whole time. That's why we have to go through all this trouble. Now that it's gone, I can let h inside here be 0 because it's not a problem. So this thing simplifies down to the derivative being negative 8 on top, and on bottom it would be x minus 5 times x minus 5, which we'll write as x minus 5 squared. And that's a hefty load to carry. But it is doable. Just no fun. Okay, so we don't really want too complicated of a fraction or too big of a denominator, because it'll just get so much worse. Okay, our next task was to find a tangent line. So let's see. We need to figure out what number we were using. 4. Okay, so we're trying to plug in 4. Sorry that I can't control everything here. So we're going to let x equals 4. So when I plug 4 in, I get x plus 3, that gives me 7 on top, and x minus 5, that gives me negative 1 on bottom. So I get the point 4 for x and negative 7 for y. And then the derivative, I'm going to plug the 4 in. Remember, that was negative 8 on top. And on bottom I have x minus 5, all that squared. So I'll be negative 1 squared, so that'll be positive 1. So it looks like the derivative is negative 8. So let's see here. I'm going to double check that. Feels okay. So we need just a little bit more room to finish this out, and then we can go to a graph to see if it's right. So we'll say y, using our point slope formula, y minus negative 7, so that'll be y plus 7, equals negative 8 times x minus 4. So we'll distribute the negative 8. We'll have y plus 7 equals negative 8x plus 32. So that won't be a lot of fun to graph, but when we get y by itself, eventually we'll have negative 8x. Subtract the 7, so it looks like plus 25. That seems to be okay. So we'll pause it and we'll go graph it and hope for the best. Okay, so to remind you, we had our function that was y equals x plus 3 over x minus 5. So this is a rational function. It looks like this. There's a break over here at 5, x equals 5. So we were looking at the point when x is 4, and we found that y was 7. So here's our point on that graph. And our tangent line was y equals negative 8x plus 25. So the function is definitely going down at that time. So as we can see there, the have the negative slope of 8. Zoom out. It looks like it's butting up against there. That function kind of takes a deep turn, so it's kind of hard to get something that looks really great. But it looks good to us. Thank you.